What is information? Information is a property of the arrangement of particles. Everything in the universe is made up of the same fundamental particles, but information is the blueprint that arranges the particles in such a way that is unique to them. For example, both graphite and diamond are made up of carbon molecules. What is different between them is the arrangement of their particles, their information, the thing which makes them, them. Information is directly proportional to entropy. And what is entropy? Entropy is a measure of the disorder of a system. For example, we see that steam has a high entropy because there's a large variance in the positions and velocities of its particles. Conversely, we see that ice has a low entropy because there's little variance in the positions and velocities of its particles. It is a predictable and orderly system which requires less information to fully describe it. This means that information should also obey the second law of thermodynamics, which states that entropy, and thus information, should never decrease over time. The problem is, this doesn't seem to be the case when it comes to black holes. You see, black holes obey a theorem known as the no-hair theorem, which states that an external observer can only determine a black hole's angular momentum, mass, and electric charge, and nothing else. If I were to throw a sample of diamond into a black hole, an external observer would never be able to tell whether the soup of carbon atoms in the black hole came from a sample of diamond or a sample of graphite. The information would be lost. This is known as a black hole information paradox, and you should care about it because if it is true, then one of the most fundamental laws of nature, the second law of thermodynamics, would be violated. Okay, don't panic just yet. It turns out that the information of the matter is conserved. More specifically, it is encoded as some kind of groove on the surface area of the black hole. Think of black holes as vinyl records. The information of the music is stored on the little grooves on the surface area of the disc. And we need a larger surface area to encode more data. In a similar fashion, the information of the black hole is stored on little areas called Planck areas on its surface. And we can play the vinyl record by analyzing the quantum fluctuations of the Planck areas. That's amazing! But this doesn't resolve the fact that even if information is conserved, it is still hidden away from the external universe due to the no-hair theorem. But according to some recent work by Jared T. Hooft, Hawking radiation itself conserves information. The grooves on the surface area of the black hole distort the photons, painting them with bits of information as they fly out into the universe. Thus, the photons escape carrying information, and the paradox is resolved.